And we're live. Hey guys, welcome to the Crowdcast today. I'm Logan, and I'm here with Anson. We'll be going over the setup to set up a Sentry node for your validator, and then we'll go into a bit on how you can automate that process by using the secure validator setup. So kind of the game plan for today's session is that we'll talk a bit about the architecture of Sentry nodes and the architecture of a full validator setup. We'll talk about why Sentry nodes are necessary for a resilient validator setup. And then Anson will go ahead and demo how you can set up a Sentry node manually. And then I'll demo how you can use the secure validator setup to do it all automated. So just to make sure you guys can hear me okay, can we get a 1 in the chat, please? Can't hear anything. Okay, so we have a few 1s. Patrick, maybe check your sound settings because it looks like everyone else can hear. All right, so instead of going through a bunch of slides, we figured we would do something a bit more interactive with this session. So what we're going to do is we're going to start with going to the whiteboard and drawing out what the Sentry architecture looks like. So let me switch over to my other tab, and we'll go ahead and do that. Okay, so for the people here, we'll kind of assume that you're familiar with what a validator is in the context of Kusama and Polkadot. For anyone who isn't, the validator is a node that is participating in the consensus by producing blocks and finalizing old blocks. So we'll write here the validator in V. So as with any blockchain, one of the cornerstone components is the decentralized network. So what this means is that your validator node is part of a peer-to-peer network with a whole bunch of other nodes. And we'll just draw out 3 of these for now. So node 1, node 2, and node 3. So these nodes are all connected to each other. So we can draw some lines between them. So here we've drawn 3, but in reality, there's hundreds of these nodes. I think Kusama has almost 500 nodes. So these nodes that make up the bulk of the network, we can consider this the public network, the public peer-to-peer network that is gossiping around the transaction data and all the block data. So in a kind of naive setup for your validator, what you would do is you would just set up your validator node as if it was one of these other nodes here. So that would mean that you're connecting your validator directly to these public nodes. And in an ideal world, that works fine. Your validator can talk to the rest of the network. It can gossip the data. When it produces a new block, it can get it to the rest of the network. Kind of the complication is that when we talk about blockchain systems, we need to think about their design in the case of in the presence of adversaries, and in the case of someone who's trying to actively harm the network. So if someone's actively trying to harm this network, a major target would be the people who are producing the blocks. So if we have an adversary that we'll draw with A, and they wanted to take out a part of the network, their target might be one of these nodes, but really they want to cause the most damage possible. So their target would probably be the validating node. So the adversary would try to, in some way, discover this validator node and try to take it down in some way. And with a kind of naive connection like this, it's more or less easy to do that because this validator node is broadcasting its IP address to all of these connections that it has. So all these nodes in the public network know where this validator is located. So all an adversary really has to do is connect to the network, query these nodes for the rest of their peers until it eventually finds the validator node, and then do something that's called a DDoS attack to take down this node. So this is a design complication. So this is what we're trying to prevent against. So let's back up a bit and try to rethink of how we can prevent this. So the solution here is to create some buffer nodes. What I'm drawing here as S, and these are called Sentry nodes. So what the validator can do now is form a form a network with just these Sentry nodes. So only the Sentry nodes know where the validator is located in the kind of network topology. Now, in order for the validator to connect to the rest of the network, what would happen is that these Sentry nodes connect. So like this and so on. So now again, if we consider the adversary, they would be able to, again, do a similar type of attack where they connect to one part of the network and eventually connect until they find where the validator is. Except now they can only get to this part, only to the buffer nodes, the sentries. So it is still possible for an adversary to DDoS attack a sentry, but it's also really easy for a validator to just keep spawning sentries. And if a validator runs multiple sentry nodes, they become that much more resilient to this type of attack. Yeah, so that's kind of like the theoretical design reason for why Sentry nodes are important to a validator setup. And yeah, I think Anson now will go into kind of like concretely how you can set that up for your validator architecture.
Yeah. So can you guys hear me? Yeah. Cool. So I think you guys can see my screen, right?
Yep.
So what? Okay, thanks. So what I'm gonna do is to basically walk through our wiki. In our wiki, we have update the Sentry log guide. So basically, what you will how to configure the Sentry log manually. So let me see. So the architecture I'm gonna demonstrate to you guys today is So we have two Sentry logs that is sitting on the public, and we have a VPN network. So we are going to use the WireGuard VPN to set up the VPN network, and the validator is sitting inside the VPN network. And then through the VPN, the Sentry can able to communicate with the validators. So it's pretty straightforward and easy to set up. So okay, let me see. Going back to the wiki. So this is our chat leaks for today. If you guys wanna walk through the setup guide, so you can go to our wiki. First thing first, I assume you guys have set up the validator. If not, you can download the Linux binary, so or the Docker image. And then you have to synchronize to the latest block, and then we'll install and configure the VPN, and then we test the connection between the validator and Sentry. So first thing first, this is the terminal. Are you guys able to see the terminal?
Yep.
Cool. So this is the validator, and the others are the Sentry logs. So we can see, let me see. So I have a validator. So basically this is the final output, what it looks like if you have set up everything correctly. As you can see, I have two peers. So these two peers actually are the Sentry logs I have configured already. So let me see. So these are two Sentry logs, and this one is the validator. So let me stop it first. Oops. Wait a second. Cool. Okay. So basically, what you are required to do first is to turn on your firewall settings, like the SSH port, the WireGuard port. We are going to use the 51820. You can change it, but default is this one. And the lib2 P2P port is a VOVVV, so only public load is required, and then enable the firewall. And then you can check the firewall settings by using this command. So this is basically the results. So if you have configured the firewall settings, then you can install the WireGuard. So it's pretty straightforward. So, and then the second step is to generating the keys. So the keys is the way for your Sentry logs to communicate between your Sentry and the validator. So because I have already installed the WireGuard, so I will let you know. So if you have installed it, and then go inside the WireGuard directory, then you should see. I have two key files. The first one is a private key, and the other one is a public key. And one more thing is we will configure a interface file just in a second. So you can just get the private key and public key. So you have to install WireGuard for all your public Sentry logs and the validator. So I have already installed it. So you can see. Oops. Oh, I already. Oops. So right. So after you generate those keys, then what you are going to do is to configure the interface file. So this is the template. So I will explain a little bit more about the configuration files. So we can just rewrite the configuration file first. So this is the validator side. So first thing first, we need to declare the address we're gonna use for this private network. So you can use any IP address you like. You can use 192 subnet, or it depends on your what you want. And the listen port, we have chose 51x20, and the private key which I just generated before. So you can take a look. So let me wait a second. So right, this is the private key, and this is the private key, and the peer is the public Sentry looks the public key. So as you can see, I have declared two peers, which is the two Sentry logs. So what you want to do is to get the public key from the Sentry log side. So what you will do is you can get the public key and then copy this one and paste it to here. So if you have, say, one more Sentry, you just adding copy and paste and then change the public key. Allowed IPs is the IP address you have defined in the Sentry logs configuration file. And then the endpoint is the public IP of your Sentry logs. Yeah, so this is pretty much about the configurations for your validators. It's pretty easy and straightforward, right? So if you have set up everything for the validator side, and then we can take a look at the Sentry log side. So we can, in the Sentry log side, we also have a configuration file. Oops. So so this is the IP address I'm gonna use for the Sentry, and this is the private key I have generated from the Sentry log side, and this is the peer for the validators, because we want to talk to the validator, right? So we need the public key of the validator and the IP address of your validator and the allowed IP address you have divided in the validator side. You can divide in a subnet. So you can divide in a subnet array in a range. So it doesn't matter whether you have, right? So this is pretty much about the configurations on the interface file for the validator and the Sentry logs. So you can check the another Sentry is pretty much the same as the other. So once you have set up everything, because I have configured already, so I can, let me wait a second. I can turn off the Sentry first, turn off. So if you have set up the VPN already, then you can test the connection between the validator and the Sentry. So because previously I have turned on the VPN, so right now I'm gonna turn on again. So you can use this command. Basically, all these command I have demonstrated right now. You can find it on our wiki, and then turn up the interface file. Then you can check the connection status by using WG or WG show. Then you should see the peer connection, transfer, receive packet. So, and then what you're gonna do is try to test the connection, right? So I can So because the IP address I have defined in the validator is 10.0.0.1, right? So I can try to ping the validator from the Sentry log, say ping 0.0.1, and then yeah, I get the response. So that means the connection, it works, right? You can try to ping it from the validator side. Okay, so it works, right? So basically, the configurations of VPN is pretty straightforward and easy, right? So not that difficult. So if you have set up the VPN, then what you're gonna do is to so because I have already synchronized to the latest block for those Sentry logs, so I can give you guys see what you are required, what facts you are required to use to start with your Sentry logs. So, oops. Oh, I already, okay. Oops. Okay. Yes. So, okay, wait me a second. So, yes. So, this is the command you are required to use to start with your Sentry logs. So, we have to use the Sentry flag. So, the Sentry flag, which is indicates you're running the Sentry mode. So, this is the flag you are required to use. And this is the multi-address. And you have to change the IP of your validator VPN address and the POC and the logs identity. So when you start the validator, so I start the validator, and then you should get the local log identities, and then you just copy this identity to the Sentry log. Just replace that, and then you can start the Sentry log, right? So, and then I can start another one, Sentry, right? I start as a Sentry row, right? So I should have peers. So once you have start your sentries, then you can start your validator. From the validator side, we need to use, of course, the validator flag and the reserve logs. So the reserve log, it means, okay. So the reserve logs means we will accept the connection from these two Sentry logs, because by default subject, I think by default each subject has the maximum 25 income or outcome connections. So if you don't specify these two, it could have a problem. You couldn't connect to those sentries you have defined. So we have to specify we want to accept these two connections. And let me wait a second. And we have also required to use the fact reserve only. So that means we only accept the connection from these two loops we have defined. So this is pretty much these additional two facts you are required to use with your validators. No, and then you can start your validator. So then you can see start the role as an authority, and then you can see I have only two peers, right? So, and then you can track the status, I think, through the telemetry, right? And then you should see it. I have 2 here, and yeah, so that is pretty much what you are required to do to configure a Sentry Logs manually. So if you guys have any questions, just put it to the track. And yeah, so I will let Logan to continue to talk about how to use the secure validators.
Thanks, Anson. Does anyone have any questions? We're gonna. I think now would be a good time to ask some questions before we jump into the next part. Okay, it doesn't look like we have any questions right now. So I'll take that as a cue to just continue. If you guys have any questions in the meantime, be sure to put them in the ask a question box located at the bottom of the screen. Okay, so Anson just demonstrated how to set up the VPN private network and the Sentry nodes manually, but there's also another way that you can set up a Sentry architecture, and this is through the secure validator setup. So who's a secure validator setup for? It's for anyone who wants to automate that whole process. So automate their architecture and still have confidence that they're running the most secure setup possible. So it's not for everyone because it does use some tooling that might sometimes require some expertise if you get stuck, but it should appeal to anyone who's interested in DevOps or any kind of sysadmin kind of stuff. So we'll be working off of the code that's hosted in this Git repository. I'll paste the link here in the chat. Big thanks to Federico from the Web3 Foundation DevOps team for basically putting together this whole setup. So I'll be just demonstrating his work today. So the tech stack that we're going to use on the code infrastructure side, we're using Terraform to provision the machines. So we provision separate machines for each node that we will be running. So one for the validator, and then one machine for every Sentry that we would run. And then we'll be using Ansible to script all of the setup commands on these machines. So once Terraform creates the machines, we need some way to run all the commands that we need to take it from a kind of raw new machine to one that's running the Polkadot code. So Ansible and Ansible playbooks are what we'll be using to do that. The secure validator setup is kind of cloud hosting agnostic, but currently only supports these ones that I have on the left of the slide. So Microsoft Azure, AWS, Google Cloud Platform, and Packet. Now you can use any of these 4 hosting providers in any kind of combination you want. Today we'll just be using Google Cloud for everything, to kind of simplify the process. But once you get it down, you can run your validator on Packet, and then your sentries on one on each, one on AWS, one on Google Cloud, and so on. It's also possible to extend this in the future. So if you're someone who wants to use DigitalOcean for your hosting, you would just need to write that Terraform kind of configuration to do that. So just some quick warnings before we go into it. When you set up your validator, you want to be careful about connecting to the public telemetry. So we'll be connecting to the public telemetry in this demonstration, but when you do it for real, you probably won't want to do that, because that exposes again possibly your IP to at least the telemetry server, and possibly to a wider audience. And also, we'll be kind of careless with secrets during this session, but when you're doing this for real, you want to make sure that your secrets, your SSH keys, and so on are secret. So yeah. And yeah, sometimes these scripts don't work fully all the way. You'll need to do some kind of tinkering, but hopefully doing this demonstration now can help you kind of work through that, because I'll be working through a couple of things that happen as I go through it. Okay, demo time. So let's jump over to, let's close this one and do you guys see the video that's focused? Okay. So now we'll be working off of this wiki guide here. And we'll just go from kind of start to finish. So the first thing that you would do is make sure that you have all of the dependencies installed locally on your computer. So these are Node.js, Yarn, which is a package manager for Node, Terraform, like we mentioned before, and Ansible. So we have here instructions for setting that all up on a Ubuntu or Debian operating system. But you should be able to find instructions fairly easily from each of these projects' documentation as well. So I've already done this before, so I won't install all the dependencies now, but I'll go straight into the deployment process. So the first thing to do is to clone the repository to one of your local directories. And then run yarn inside of there to install the project dependencies. So I've cached that in the past, so that's why I ran really quickly. Yeah, and then so what we'll do next is generate the SSH keys. So like I mentioned a little bit earlier, what Terraform will be doing is provisioning completely new machines. So we need a way to later connect to those machines. And for this, we'll be using these SSH keys that we generate. So we'll need one for the validator machine, and then we'll generate one that will be for each of our Sentry nodes or the public nodes. So we just need two different keys. and we'll leave out the passphrase. So we'll do one for the validator and we'll do one for public. Okay, and then this step here is to add these keys to the SSH agent. And then we'll go ahead and configure our deployment. So let's open up this repository in an editor and look at what we can work with. So in the config directory, we have a sample configuration, main.sample.json. And this is kind of what's provided to understand all the different options that we have for deploying this architecture. So what we'll do is we'll go ahead and copy the config to main.json, and we'll start to edit that. So we'll name the project Logan demo. The Polkadot binary. So we need a way to download the Polkadot code. Instead of building from source on all of the machines, it's a lot faster to have a pre-built binary. So this is where we can actually fetch that binary. So by default, we fetch it from the Web3 Foundation binary build page, where we have each of the binaries for all of the releases built automatically. So we'll be downloading the latest version of the code. And we have also the checksum. So we make sure that we verify the integrity of the code of the binary that we're downloading. So one of the optional features of the secure validator setup is the node exporter. So this exports some of the data of your node to Prometheus. So it's optional. You can change this to false if you don't want it, but we'll just go ahead and go with it. It doesn't really matter too much on the deployment, so we'll just leave it in. So the next step is to configure where we're going to keep the state. So for this, we need to say which project we'll be using. And I believe for the state, we can only use Google Cloud. So we'll be using Google Cloud for all of our validators and public nodes as well. For now, I'll just leave that as the default and change that in a little bit. Additional flags is any flag we want to run on our validator. So your validator will have some populated automatically, including the name flag. So it wouldn't do anything if you add the name flag here. But these can be used if you want. If you want to just run your node with some different options. And then we have the validator configuration and the public nodes configuration. So the first thing here is the telemetry URL. So we'll change that to the public telemetry just so that we can check our node once it's deployed. Again, when you're doing this in a live setting, it's better to connect to a private telemetry that you've deployed yourself, or to no telemetry at all, because connecting to the public telemetry does leak some information. Logging filter, we'll just leave that as is. And then we have nodes. So here's where we specify in this array, each object is our node configuration. So we'll replace this one that says packet with one that will deploy on Google Cloud. So I'll copy the configuration from down here for Google Cloud, and I'll leave everything default except for SSH user, which I'll change to my name, and then project ID, which I'll change in just a minute. And now public nodes, kind of the same options. Under the nodes array, we have each of these being one of the sentries that we want to deploy. For the demonstration, I'll just do a single Sentry node that's hosted on Google Cloud. Okay, so the next thing is we need to create a Google Cloud project because we need to populate this project ID with something that's not the default. So to do that, we can go to the Google Cloud console. And create a new project. So I'll call this Logan demo. And it takes a few seconds for this to configure itself. But once it does, I can click and access it. And I can find my project ID right here on the main page. So in this case, the project name, Logan Demo, is also the project ID. Sometimes they'll add some extra numbers to the end, depending on what name you pick. But apparently Logan Demo was unique enough that I can just use that for my project name. So we'll go back to the configuration, and I'll replace the default with Logan Demo. And also up here where it says configures the state project, I'll also make that Logan Demo. Okay, so now we have the full configuration to work with the Google Cloud project that I've just created. Before we run the script, there's one more thing we have to do, which is get the authorization keys. So we need to authorize the scripts to actually access my Google Cloud. And the way we can do that is to find the option for service accounts. We'll just, again, call this Logan Demo. When you select the role, you have to make sure that it has the correct permissions. So we'll make this the project owner so that it has all of the permissions to modify this project. And at the last option, we have create key, and it gives us two options for key types. The only one I really have experience with is JSON, so we'll just go ahead with create that one. And now we have the JSON key, so we'll click done. I downloaded that into my downloads folder, so I'll copy it. Copy it here. And I'll run gcloud auth login just to make sure that I'm logged in and authorized into my account. Okay, now we need to set the environment variables to this authorization configuration as well as to the SSH keys. So there's Google authorization. Hold on, let me look this up. Here we go. So we set the environment variable Google application credentials to that JSON that I just downloaded. We also have to set the SSH keys. Oops. SSH, ID, RSA, public. We do it once for the public SSH key and once for the validator. Okay, so now this should be everything we need to configure. Let me just make sure I didn't miss anything. Oh, that's all right. So the last thing we need to do on Google Cloud, at least, is to make sure that we have the compute engine enabled. So the compute engine is kind of just the how it creates the VM instances. So to do this on your account, you will need to have your billing enabled because the compute engine isn't covered under the free plan. And for this reason, you have to manually enable it, and it takes a few minutes to do that. So I'll just check if there's any questions. We'll wait. Just should take just 1 minute. So once the compute engine is enabled, what we're going to do is run the script that's provided in the repository to deploy this. So what this script will do is again, provision the machines, create completely new compute instances on Google Cloud, and then SSH into these machines and run the Ansible playbooks. So hopefully this runs all the way through. We might have some a little bit more configurations to do. Actually, I guess I'll just do those right now. So there's one possible bug you might run into with SSH keys. So what this is the scripts will generate the public key for the private keys that are that I gave to it in the environment variables. But there's some kind of a bug with actually sending those keys to the compute engines. So we have to actually put those keys in manually. So those keys are generated when we generated the SSH keys before. So we have the public keys for the ID RSA public and the public key for the ID RSA validator. We'll have to change just one thing at the end. So instead of showing my operating system name there, we'll change that to my my email address or the account of my Google Google Cloud user. So this is so that when I use the private keys that I have, the compute instances know that they match up. So I'll just add those two in now. and save. And the compute engine should be up by now. Yeah, I think that's what this says. Yeah, so done. All right, and now I can run the deploy script, and fingers crossed that it works the first time. So I'll kind of talk you through what's going on here. Demo. Okay, so usually when I run into this, the issue is that I didn't auth my account. We'll try that again. And then let's change this project ID to Logan demo. Again, maybe I need to log in now that I've changed the project. It's also possible that my authenticated or application credentials are not being passed in. So let's make sure that those get passed in for sure. Okay, so, so, sorry, that name is not available. So I was running into this before, but I was able to get past it just by authenticating myself. Let me just check. Does this say it's the owner? Yeah, I'm pretty sure I set this as owner when I created it. So let's try this one more time. Oh. Okay, let's try that again. Logan demo 2. Project owner. Update that. Continue. Okay, so maybe that's what I needed to do was update the security policy. So it might be a better idea to, instead of creating this first and then enabling compute engine, to enable the compute engine and then create this. So let's go ahead and pull that one in. Logan demo. Oops, which one's this one? 40. Okay. Fingers crossed that was the issue. Okay, so maybe this is where I'll get hung up here. We'll try it, I guess. Oops, did I? I'll try it, I guess, one more time. Yeah, so it might take a while for these keys to actually activate. So yeah, so that might be where I get hung up here. But yeah, and in a so when you have this set up, ideally, you'll be able to run that script, and it'll run everything for you from start to finish. So yeah, if we have any questions, feel free to ask them now. Anson, do you have any ideas of what could fix this?
Not really. I haven't encountered this problem before. I guess, as you mentioned, you may take some time to activate it.
Yeah, I think that's what it is. Okay, maybe. Let's see, maybe. Okay, so sorry about that. So I forgot that that was a possible issue as well. So one of the possible issues is that Google Cloud uses a global namespace to create your bucket. So if you use a generic name like I did, Logan Demo, it'll throw that error. So yeah, I added some numbers to the end, so that seemed to have fixed it. So yeah, so that was a lot of kind of debugging to figure out what went wrong. But hopefully, hopefully, I guess anyone who's stayed tuned now knows how to solve that if they run into it. But yeah, so we can see here that it is indeed running. It's completed the Terraform process, which is provisioning the machines. So it's spat out some IP addresses here. Now what it'll start doing is Ansible. So this is a problem that I've run into before. What will happen is that it'll say unreachable, and it'll say it failed to connect to the host because the connection timed out. Usually, what the problem is that the pause between the provisioning of the machines and the trying to access them is too short, so that the machines aren't actually ready yet. So we should just be able to run this again, and it'll make it through that process. that kind of looks. So if we go back to the Google Cloud account, we can look into the compute engine. And see that the machines have actually been provisioned. And we have Validator and public node. Fetch token. So this looks like just a connection issue. So the good thing about this script is that it'll automate everything, but if there's some kind of problem in the middle of it, you can just run it again, and it'll just skip over everything that's done already and pick up where it left off. So we're back at the Ansible playbook part. And each of the tasks here, it'll let you know what it's doing. So currently what it's doing is installing Apache 2 utils for the node exporter. And usually if I get this far, it'll complete. So I think this is the one. Yeah, while that's running, we can we can talk a bit more about what if you have a problem, how you can connect into these nodes. You can come into the Cloud console and SSH into them just by clicking that button. Let's check back to see what our playbook is doing. Okay, so our playbook now is running through the VPN setup. So the steps that Anson showed you before with setting up WireGuard, that's what the scripts are doing in an automated way now. I hope this doesn't time out. So yeah, once you're into your machine, if you need to kind of debug anything, I think the most helpful place to look is inside of your systemd directory. So that's located a little bit bigger. It's located here, etc systemd system. Because what the playbooks will be doing is creating a system file for your nodes. So back at the playbook, we have it's setting up the Polkadot binary. It did the checksum, and it's currently checking if we have the service already running. And if it doesn't, it'll set up that service itself. So it'll first create the dummy config just to make sure that everything is right with the configuration we have before it starts the actual configuration. So it looks like it completed through the dummy step. Again, it's doing some stuff with the VPN, but now we should be able to check with the connection we have to the machine, and it has the Polkadot service file, as well as the node exporter service file, which was created by our Ansible playbooks. So we can peer into that. So unit description, Polkadot dummy node. That's what we expected, and just kind of dummy stuff to make sure that everything worked. What it'll do next, it'll create the actual system config. So here we go, creating Polkadot service file. So that dummy config should get replaced, and now it's restarting. So if we look at that, let's see. So it looks like it's done that for the public node, and now it's doing it for the validator node. Yeah, validator, create Polkadot service, restart Polkadot service. Check if keys already exist. So these are the session keys. It'll initialize the session keys and print us out the output. And there should be 2 steps left, I think. Or just a few. Saving the session output. Okay, I think that was the last step. Oh, a few more steps to go, apparently. There we go. Okay, so that's what it looks like when it's completed all the way through. So hopefully that runs for you the first time, and you don't have to kind of debug why your authorization is not working like I had to. But yeah, let's verify that this actually set up the nodes. So first, just to complete what I was showing here, I'll show you that it's created the new Polkadot service file. So this is the real one. It says my name is Logan Demo 33, and that I'm connected to, I'm using the only reserved nodes. Some other options with logging. It'll say which reserved nodes I'm connected to. So this is my Sentry node. And then it'll say I'm connected to the public telemetry. So let's just go ahead and verify that as the last step here. Logan Demo 33. And we can see that we have the SV public node, which is the Sentry node, with 31 peers on telemetry. 31 peers. And that we have the validator node here with 1 peer. So that's how you can set up the validator and Sentry architecture using the automated deploy scripts. So yeah, thanks everyone for tuning in. I hope you learned something about setting up your Sentry architecture. If there's no questions, I guess we can conclude the session. Any concluding words, Anson?
I think if you guys have any questions about validator, staking, or nominations, just ping us on Riot. Yeah, or check out our wiki.polkadot.network.
Yep, we're always available on Riot. So yeah, hit us up there. Thanks, guys. See you next time.
Thanks. Bye.